Hi friends, today we are going to present a topic machining of mold of a vent turbine blade using Autodesk Fusion. We are using two softwares, that is SolidWorks for modeling and the Autodesk Fusion for the machining process. Okay, the steps which we have followed is first we have designed the model of the turbine blade using the SolidWorks 2017 and we need a exact model for the mold. So again we process the mold model by the SolidWorks. Again we converted the file into the IGS and exported to the Autodesk Fusion, and the male and female part of the die is separately modeled according to the different uh, topological. Okay, let us get into the process. Okay, first we have shown the model. This is a turbine blade we have designed at first. We have the 17 profiles of aerofoil sections. The profiles was generated by the NACA Java software. It interpolates the different aerofoil shapes. From that aerofoil shape we have imported on the different 18 planes. From the 18 planes we have used the command called loft boss. The loft boss command has left out the different sections of the profiles and made this turbine blade. Again, we are focusing here about the fusion machining only, so I just skipping this designing and model section. This is the aerofoil. Just for a glimpse I'm showing here. um, this is the front view of the turbine blade. This is the top view. You can see the aerofoil sections here. Here after the loft you can see this is the type of loft. This is a fully generated turbine blade section. Now we are interested to um, design this turbine blade mold. So for that we made a female cavity by generating the off of the aerofoil section, and we created the extrusion operation. Then we have followed the machining process in the Autodesk Fusion. You can see after IGS conversion of IGS file, we have imported the file into the Autodesk Fusion. Three dominant operations we have used here. Actually, two dominant operations. We have for precision we have used the adaptive operation in the second time. Okay, first you can see adaptive adaptive machining process. In this adaptive machining process, as you know, first process is we have to align the stock. You can see it here. See, in this first level operation we don't know which are the machining, which are the size, which are the tool length, dimensions. We have to predict it by assigning few trial methods. So first we processed by like that. Again we have get a clear idea, then we have arranged the full process by assembling this swarf and adaptive process. And here there is, you can see there is no error in this operation, as I have playing the clip it doing the operations. Have you noticed the process is fully mentioned by the green line? So there is no error. So we are getting a fully generated machined lower female part of the mold. Thank you. The further process of upper mold part is generated by my friend Mr. Gopi. Let him to explain the further process.
Hello,
Thank you.
good day everybody. I am V. Gopinath. I have modeled a horizontal axis wind turbines blade using the software Autodesk Fusion 360. This is the isometric view of the turbine blade. I also wanted to simulate the manufacturing process of this wind turbine blade, which is made using the process vacuum infusion. For this, a prepared mold of the turbine blade is needed. So for that, the lower half of the mold has been created the same using the software Autodesk Fusion 360. So using this half of the blade cut along its lateral axis, a mold has been created using this sketch. So this is the mold, and the cut operation was used to cut off the material of the body. The Boolean operation subtract was used, and finally we got the mold of the horizontal axis turbine blade, the lower part of the mold. Now let us see the manufacturing simulation of this. This is the setup, stock setup, and this I have set this as Z axis for the tool motions path, and certain X and Y axis has been assigned accordingly. I have left no additional stock for this. Now let us see the simulation. I shall speed up the process. I have used adaptive 3D cleaning, adaptive 3D clearing for this process. So thus we have finished manufacturing the lower half of the mold of the wind turbine blade. The total machining time taken for this was, actual machining time is 1 hour 10 minutes 44 seconds. Thank you for watching.